Good evening, everybody. Welcome to Mastering the Zen of Dev Experience, Kubernetes and the Art of Simplicity. That was way too overly dramatic, wasn't it? This evening, we have my good friend, longtime contributor to the show, and AWS Hero, CTO of 6 Feet Up, and all around astonishingly good guy, Hendryx-Parker. Calvin, how are you doing today?
I'm doing really well. Thanks, Chris, for having me on. I think it's my second time on vBrownBag. I guess I must not have messed up so bad the first time you had me back.
No, you've been on like 2 or 3 or at least 4 times. Yeah, you've been on 4 times now. That
could be.
Yeah,
no, I'm super excited to be here. I really love the work you're doing in the community, and anything I can do to share some cool stuff. I would want to be here and hang out with you.
Hey, Stephanie's in the audience. Hey, Stephanie, how are you doing? Stephanie is one of my favorite people. She's always on the show. Before we get into it, let's do a couple of show notes. Get in on the conversation. If you at vBrownBag anywhere, LinkedIn, Twitter, Threads, Instagram, YouTube, that's us. That we are there. Get in on the conversation. If you are in the live studio audience, we will be paying attention, as you can see by me saying hello to Stephanie. Why Calvin 6 Feet Up? Oh, we will get into that. That's a great point. That's a great question.
Why 6 feet up?
Yeah. Why the name 6 Feet Up?
Okay.
Yeah, I know the answer, but we're tabling that for 2 seconds because we're going to be getting into some super fun stuff. My name is Chris Williams. I will be your host and your question relayer to Mr. Calvin Hendryx-Parker. I am an enterprise architect, and I am a developer relations manager for the company HashiCorp. Calvin, would you like to introduce yourself to the audience, please?
My name's Calvin Hendryx-Parker. I'm co-founder and CTO at 6 Feet Up. We have been around for 25 years. Oh my gosh, the dog. So Chris, my dog, just got back from a walk and decided he wanted to come up here and squeak his toy. So
I can hear the squeak toy. Hey, Mushu!
This might be a problem.
No, it's not. No, it's not, because he's in the slide deck.
He is in the slide deck. That's true. He is in the slide deck.
Not even a problem.
Yeah, but we've been around the Python community almost since our inception. I think I started using Python at version 1.5, and I couldn't get enough of it that I had to found a company to basically try and do that full time as often and in as many places as I possibly could. So big involvement in the Python community, numerous open source projects where I've been involved as well. As far as 6 Feet Up goes, we are a team of expert, ninja superstar developers who love solving hard problems. That's kind of our really favorite thing. Is if something has never existed before, that's where our team really shines and loves to come in and do really cool stuff. So we're doing a lot of AI, a lot of ML, a lot of big data. If it can involve Python in some way, that's definitely in our sweet spot for sure.
Yeah, so I just looked at the deck or not the deck, excuse me, the playlist. You've been on 4 times. You did 2 during the Python year, the Python series that we did during the pandemic.
Oh, yeah.
And then we got together 2 additional times afterwards for just regular shenanigans and monkey shines.
Yeah, because Chris, I might be getting a little on in years, and so I can't remember everything apparently. Don't tell anybody though.
Okay, I won't. We met in the before times. We'll just leave it at that. We did meet
in the before times, that's for sure.
Awesome. So what I'm going to do is I'm going to flip this over here. Ta-da! And now, Stephanie said we can barely hear the dog. We all have pets.
Okay. Thank you, Stephanie, for allowing me to have my dog here. He's hanging out in the background now. I think he's going to chill. He's excited to be here with us.
He's doing his thing.
The dog loves talking about Kubernetes. It's pretty crazy, quite incredible. We can address that first question actually about 6 Feet Up. So it's a fun name, fun story. Back in about the year 2000, my co-founder and partner for life is also my wife, Gabriella, and we were sitting in San Francisco and thinking about a name for this venture we were getting ready to go out on, and searching for domain names, as one does. First thing you do when you're going to start a company, you got to find a domain name, and it felt like all the domain names were taken. And so we searched, nothing coming up. Oh man, it's really tough. So I think she walked by, and I was at the computer typing. She's like, "Why don't you do play on words of the family business?" And the family business has been the mortuary business. So my family's been in the mortuary business since 1888, putting people 6 feet under in little boxes. And we said, we're going to keep people alive and kicking and call it 6 feet up because that seemed like a more appropriate direction to go. Domain name was available. And here we are.
Shazam.
Shazam. now you know. The more you know. You should have the PSA little graphic go by with the star. The more
you know what? I need to start doing things on OBS so that I can start doing that. Like have the more you know.
I mean, how many years have you been doing this for? You got to step this up.
Only 13.
Yep.
Look, we only switched to Adobe Premiere in the past 2 years. So this is the incremental change, positive change is glacial here.
It's about stability.
It's about the content. We care more about the content than sparkly happy stuff.
For sure.
And I'm lazy.
Well, let's talk about some sparkly happy stuff.
Let's do it.
Should we do that? All right. What's funny is like when Chris announced the title of the presentation, the Zen of the dev experience, the next part is what usually trips people up, which is Kubernetes and the art of simplicity. Because I don't think those two words typically line up in the same sentence very often, but I'm here to try and convince you otherwise. And feel free to ask questions along the way. Make it as interactive as you want. Chris, please interrupt me anywhere along the line. You know that is totally fair game.
100%.
So that QR code that's on the screen right now is actually a QR code directly to the GitHub repository for this presentation. So if you want a copy of the slides or you want to see how it's built, it's all done in Markdown on the backside. And then the next, in about 2 slides here, will be the link to the project we're talking about that actually makes the developer experience in Kubernetes simple. So let's get started. So first of all, the obligatory cat picture for the presentation is right here. That is my cat Macintosh. He is 19 years old and still kicking around. I'm afraid he's going to live another 10 years. So we'll see what happens there. So that's Mac. And then there's the dog in question. That is Mushu. Mushu is an awesome dog, and he's sitting right behind me back over here. So if you throw him a bone, it's all good. He's be very happy. So he's hanging out. So those are the obligatory cat and dog pictures. This is what we're actually going to talk about. I'm giving you the link now, so if anybody wanted to check it out right away or have it kind of open in another tab as we kind of go through it. But we're going to talk about Scaf. Scaf is a developer tool for busy devs, and it's a way to bootstrap new projects really quickly. And currently, it's aimed toward Django-based projects. So we're going to do a demo, and I'll show that off a little later. But as we get into this, I will basically talk about that ideal developer experience, and then we'll do a demo, and you'll see Scaf in action, and you can kind of ask more questions because there's a lot packed into that one tool. But the idea here is, how do we get to the ideal developer experience? This is something I love geeking out about. I like talking to other technology leaders, and I like to talk to other people who are doing implementation and the actual engineers and software developers who are doing the project, because it's important, I think, for anybody, because you don't want to waste your time. How fast can a developer get started on a project, or how fast could a developer onboard onto a brand new team and produce their first code that could be in a PR, off onto some staging, or even into production? I kind of find that's a measure of a maturity of a development team. So thinking about that ideal developer experience, it'd be awesome if you could hire a new developer, onboard them to the team, ship them a brand new MacBook Pro or a Windows machine or a Linux box. And I would love to see that in the first hour they open that machine up, that they could actually be productive. They could.
That was Mushu saying, first hour? That's impossible.
That's nuts. It's crazy.
That's bananas.
It's nuts. It is bananas. So the first hour, think about that first hour of I should be able to install Docker Desktop or some kind of container environment. I should be able to install my IDE, whether it's VS Code or PyCharm or whatever that case might be. And then I should be able to pull code, clone my repository down to my local machine, and then optimally get, like I said here in this very first bullet, set up in a few minutes, get clone, and then we're angling toward a tool called Tilt. And so with Tilt, you should be able to get clone and tilt up, and I should have a running local instance of the application, the full stack. everything from the Django backend, and maybe you've got a Next.js front end, you've got a Redis cache in the middle, or Valkey cache in the middle, Postgres database in there, maybe Mailhog as a email development tool, all running, and it's all just going. I think the big holdup in the past, or maybe, and I say the past, it's probably a lot of people's current reality, is that they would have to go through like maybe a document or a README or a getting started, set of instructions, and it could take them literally a week or more to get started, because they have to get the right version of the database installed, the right version of Redis, the right version of, you name all these tools, and then they haven't even gotten the developer niceties in place, like all the debug tools. Can you run a debugger, set a breakpoint, and interrogate that code and debug a problem, like being productive? And so that's just the first issue on this list of the ideal developer experience. The next being, do you even have enough resources on your laptop to run all these things simultaneously? RAM, CPU, disk. When you start talking about containers, or not containers, you could be using, if you have a 16 gigabyte of RAM machine, that could be far too small to try and run all this locally. So what is a developer to do? I'll talk about that. And then having it all containerized. I would love to see that the development experience uses containers, because then all the developers are running the exact same stack. And I don't care what platform you're on, whether you're on Mac, Windows, or Linux, it really should be work alike. Like the tools should work alike, my tool chains should be compatible in all those places, because the ultimate deployment environment where we're putting this is going to be something similar, or look similar anyway, like some kind of container-based solution for that. A part of this experience also should involve good continuous integration and quick deployment. So having that quick iterative feedback loop. Do you have these kinds of tools in place? Is it easy to set up? Are you using a DevOps platform like GitHub or Azure DevOps, or whatever the other ones that are kind of out there in the ecosystem? Are those set up and ready to go? And then can you have things like automatic preview environments? It'd be nice if you're a developer. And again, I think a lot of developers, their workflow may involve everyone logging into some one server where there's a test or development instance, and hacking on the code simultaneously with one another. Throw source control management to the wind. We've got bugs to fix, and I believe that is still some people's realities, and I want to try and find them a way out of that. So having the ability to even have your own deployed environments. So for example, I can get a bug, fix the bug, create a pull request, create a preview environment that is not the sandbox or the production or the staging environment, so it can be tested in isolation from other code that's going on at the same time. So we can actually increase velocity and have less adverse code interactions and less weird triaging having to happen, because you're now trying to track down some weird interaction bug. You can basically test what your fix in its own isolation in a preview environment. And then the ultimate on top of all this is, can I use the same tools actually to debug dev, QA, and production environments? Am I running the same stack of stuff along the way? I think you may see in some environments, people may run on their local workstation or a shared dev instance in the cloud someplace. Maybe they've got an EC2 where they log in and dev. And when they go to QA and production, that's a matter of them shelling into some machine, potentially doing a git pull of main or some tag to that machine, and then rebuilding in that spot. Or maybe they release with containers, but they develop without containers, which makes it difficult if you wanted to debug a really tricky production issue where maybe it's only manifesting itself in production when it's hosted in a containerized environment, and now you're stuck on your local machine trying to run it locally and can't see the bug. So there's lots of potential Heisenberg bugs like that I think that this ideal developer experience can make a lot better.
Heisenberg bugs that are there until you don't look at them.
Well, I'm sure all of your viewers here have seen a Heisenberg bug. When you look at it, it doesn't happen, but when someone else looks at it, they do see it. Quantum bugs, bugs that only happen under so much load, bugs that only happen
using that
in certain routing paths.
I love that.
It's not mine. I can't claim it. I don't know where I first heard it, but I will definitely use it because it doesn't.
If you had not told me that, I would have said Calvin Hendryx-Parker taught me this.
Yeah. Make sure you cite your sources. So
I do find it it seems, I mean, when you said it out loud, I was like, do people really do that? Yeah, doing things in containers, but then in production, it's not in containers.
Yeah, that happens too.
Yeah. Okay.
It's a thing. I don't know if I can't see the show of hands because obviously we're doing this virtually, but I bet there are folks watching right now who are doing all those things and having trouble with all those things.
Okay.
So, what is a good open source developer to do? Is to scratch our own itch. Like we feel like we have a lot of experience in this, and we would love to be able to solve this kind of problem. For example, the dev laptops can be underpowered, can't run as a lot of large stacks. That dev environment may not set up with remote development in mind. So this addresses that like small, like anemic machine. It would be nice if you could have dev environments that you could attach to and debug if you needed to. I think a lot of people run into Docker permission issues. It can get kind of daunting when something doesn't go, the happy path on an install. Little support for developing inside of containers. That's my beef with a lot of tooling. It's hard to debug sometimes inside the container. Being able to set a breakpoint and use a debugger is a huge power, like superpower that any developer should be able to wield at any time. And I think a lot of developers are still stuck in the print logging era of like debugging and trying to triage an issue. It's not that you are a bad developer, it's just you haven't seen the technique or don't know how to get to that next level to leverage the full power of debuggers like inside of VS Code and PyCharm. And then debugging in a QA environment can get really tricky because you may have lots of permission issues, access issues, and you probably don't want them touching things like QA or production. But be able to bring those containers back from a QA environment to a dev or a local environment can actually allow you to debug those issues using the exact code that's running in that environment, but not having to have access to that environment. So when you think about security and least privilege and making sure only certain people have access to the right things they should have access to at the right times, this type of a structure I think is going to enable that.
So it answers the those governance and security questions that the sec team always comes up with.
Yeah, and that's part of our goal is to be ops friendly, but also very, very developer friendly. I mean, it's about the developer experience, but if the developer experience is how are we going to go wrestle with ops right now about getting access to something, that quickly becomes part of the developer experience.
Right. All
right. So my answer to that is Kubernetes to the rescue, which again, I think sounds probably odd to a lot of folks. And it did sound odd to me. I held out a long time on containers and held out even longer on adopting Kubernetes for the sheer fact that it is a very complicated, very sophisticated set of tooling to enable certain patterns. And I think a lot of people have heard a lot of, FUD or, misinformation, and some of it's true. I mean, there is a lot going on under the covers of Kubernetes, but is there a way we could simplify it to make it more accessible to those who can actually reap some of its biggest advantages? I know that, they maybe say like, well, my software project is too small. We're a very small development team. Maybe we're only a development team of like one or two or a handful of people. I claim that this can still apply to even those size teams. And I think a lot of folks know that Kubernetes was developed by Google as kind of their orchestration layer for the things that Google does behind the scenes as their internal project called Borg, and then they released the open source version of this called Kubernetes. But in the early days, it was really hard. I mean, you're not a YAML ninja, and there weren't sets of toolings around it to make it easy, or someone hasn't laid out these patterns for you in an easily approachable way, there's no way I would approach it. And that's why I didn't. And that's why I didn't pick up containers until we started doing development on the Loudswarm platform. So when we developed the Python Web Conference Loudswarm platform in 2020, that was 2020. Mm-hmm. That's when I started doing containers. So I'm relatively new to containers because obviously they've been around longer than that. But I'm here to convince you that this is a good way to go. So you can think of it again. I'm going to give you a little brief primer on Kubernetes in the way I see it and the way we view it for a developer. Is that basically it is that building plan. As building plans have or as construction has plans for buildings, it requires you to describe a desired state, and that's what's known as the manifest. So you'll hear about YAML inside of Kubernetes called manifests. All that is saying, I expect this thing to happen, and then you can hand that off to Kubernetes and it'll make those things happen. And then if things change, your manifests change, your plans change, it will ensure that it reaches that consistent state at some point. You're the architect, you are the Kubernetes, and Kubernetes is the builder. There's no manual commands required for deployment. We want to be able to use tooling for the CI and CD environment to deploy our code for us. There's nothing worse than getting onto a server and releasing some new code, and you do a git pull, and things end up in there that you weren't expecting, that weren't tested. They just got pulled down from the Git repository, and you just rebuilt onto that mystery set of code. It'd be nice to be able to deploy something that has been built and tested in one environment, and then deploy that over into your production environment with no changes to that container. So what you are deploying, you are sure is going to work. And so like this, it does more, but I think the real superpower for me and for our view of Kubernetes is not the orchestration layer of Kubernetes. And sure, it can make sure that your processes keep running if, for example, if a process dies or there's some kind of a seg fault. Kubernetes as an orchestrator will pull the thing back to life for you. But that's not the real power, I think, as a developer. The real power as a developer is being able to use the control plane to control and automate the releases coming from your CI environment. So if it passes all the tests, you can set up however many rules you want in that process. You now have full control over that process, and it talks to the server over an API. So that control plane is an API that you don't talk to as a human being necessarily. You may have your continuous deployment environment talk to it over the API to do the release. So that's why I like it, because it's basically that controlled, automated, click push button, release process. And no humans typically get involved in that, other than they test, they approve that that they've closed all those bugs. That's what your DevOps platform is for. And once it's passed all the tests, it gets released, which is nice. You can just merge that, PR, that branch, or whatever the case may be, and it will move the containers, the same container that you tested, into the new environment. All right, let's take a quick look at some what's going on behind the scenes when it comes to the Kubernetes. Actually, what I'm gonna do is we're gonna actually build a whole environment here from scratch on the file system. I did a quick first run I called vBrownBag 001, but we'll do another one. So I mentioned at the very beginning that we're using a tool called Scaf, which is an open source project to scaffold out brand new projects. So we're going to do one from scratch. So you can see there's a vBrownBag up here. I'm just going to do like vBrownBag 02. So it's fresh, brand new instance, and you'll get to see kind of a feel for this. And then we'll look at the Kubernetes manifest, and then we'll go into a bit more of a developer demo part of this afterward. So this actually pulls a container in, and then if you're familiar with the cookie cutter project, it's basically a way to scaffold some templated code to put onto the file system based on these questions. So in this case, I've got project name and slug. I'm going to answer the defaults here are all going to work for us, but it allows us to set up some things like what's the name of the project and what's the project slug and who's the email and what domains are for and what times the thing hosted in. Am I going to be hosting in AWS? What region? Maybe I can set my account IDs so they could do a release automatically for me once it's all done. Mail services. Do I need to use Celery or Sentry? Those are all options you can kind of bring in here. You can configure it for different DevOps platforms along the way as well. So in this case, we're going to use GitHub. We're using it under the 6vep org, and we'll call the repo vBrownBag 002. And so it sets up a repo URL. And when it lays down these files on the file system, it actually goes in and inits the Git repository, because that's one of the things I always forget to do when I'm starting a brand new project, is I will literally go in, scaffold out some junk, and I'll forget to do git add, git init, git add, and git commit. And and then I'll be like 2 hours into working, and I'm like, oh no, I have no history, I don't know where I started. And so this solves some of that problem. And then what you just saw happen there actually was it pulled down all of the requirements for our Django project and actually built and pinned those requirements into the current version of the code, and then it committed it. So if we actually, I can look at the project right now. So we'll go into vBrownBag 02. But what I'm going to do is I'm actually going to open it up here in PyCharm. So let's go to there, and vBrownBag 02. We'll open it up as a project inside of PyCharm. My awesome project. Here we go. And the first thing I wanted to give you a tour of, because we're talking about Kubernetes right now, and you can see right there, I think we talked for maybe a minute and a half, and I built a whole project that is got Next.js front end, a Django back end. It's got Postgres running, and then it actually has configurations for your sandbox instances, your production instances. But what we're dealing with right now is our local instance. We want to be able to play in local, and so we use the customize to be able to set up settings that basically overlay on top of a base set of settings. So for example, if we look at the config map, this sets up environment variables inside the Kubernetes for us. That's what drives the configuration of like things like the Postgres DB user and password and all those kinds of things that are inside the actual cluster. So we tried to split it up into very easy to understand little components. But generally, as a developer, you shouldn't be diving in here unless you are adding some new service or some new backend piece. We're not going to be dealing with the ingress, the all this Redis stuff, or all these kinds of like configurations. But this is the plans for the application, and we're going to tell Kubernetes to actually deploy them into our Kubernetes cluster. So that's just the basis of where all this is going. And then later, I'll scroll that down there. Like when we want to release onto the sandbox, we're going to want to be able to take and do things like create secrets and have them be encrypted and stored in a very secure manner, and actually have them be tied to each environment. So if someone ended up with a production secrets file on the sandbox environment, they couldn't actually decrypt them because it depends on the operator from the production environment. So again, keeping those least privileged kind of concepts at play here is something that was actually really important for us. And if you're curious to dig into how to do that, the makefile is actually a good place for you to start. You can see there's various targets in this makefile, and one of them is secrets. So you can actually set up staging secrets, sandbox secrets, prod secrets, and those just show, that's basically the example. I'm trying to run it right now, but that would be how we're managing the sealed secrets that are inside this opinionated set of deployment tools. And I guess I should kind of back up a little bit too. One of the reasons we did this was I think every developer should have access to all the fun, awesome tools all the time. And a lot of times they may waste a bunch of time getting set up on them because they don't understand, they're new to them. It's a whole new like learning curve for certain tools. Like for example, learning how to use sealed secrets like that. I mean, that's something that can take you literally weeks to learn and get right because of all the trial and error you're going to go through. We wanted to give good like pre-baked examples of how to do these things, so it should be simple for you to do that. So that's kind of the bit there. So that's the extent of like YAML I think I wanted to show everyone here. For example, setting up Postgres, running on a local port. Those are the kind of things we just set up for local, and then Sandbox and Prod have their own environments, and typically get released via. We're using Argo CD in our case for this. So if you actually look right here, there's an Argo CD that's going to get set up. We've got READMEs in here for how to like basically get all that going for you. So you don't have to figure it out. There's a blueprint and a way forward for you to using Argo CD for your continuous deployment pieces. So that's the YAML bits I wanted to show there. So then, kind of staying on the Kubernetes line for a bit longer before we get into some of the Python code. Oh, we'll allow that to happen, I guess. we want to
whatever that was, just allow it.
Yeah, I allow all of it. Go for all the things. But I find that, like I mentioned this before, as Kubernetes standardizes this deployment stack, like the same technology that it releases onto my sandbox or my staging environment is also the same technology I'm going to release onto production. And for the most part, the sandbox and production layers are just a difference in a couple configurations, a couple secrets, a couple DB connection URLs. They should be, fairly lightweight when it comes to that. But then more importantly is like this Kubernetes actually allows me to do the exact same thing on my local machine or my local environment. My local environment doesn't have to be my local machine. If I've got a machine that's only got 8 gig of RAM and it's barely a text editor, I should still be able to be productive. Like I can actually launch this into an EKS cluster inside of Amazon or EC2 instance or a DigitalOcean droplet and spin up a Kubernetes cluster there that is my local environment. but I've got my kubectl set up locally to point to it. And so all my tools will now point to that thing in the cloud that does have more resources and can run the whole stack of software where I can't possibly do that on my local environment. So this Kubernetes gives us the ability to switch, like you're mentioning at the bottom, from a local to remote development environment and back and forth. So that same technology allows us to release at a really consistent and reproducible and repeatable way. Gives us the same technology allows us to do development on a local dev environment, which is local or remote. Doesn't matter. I don't know if you had any more questions on that part, Chris.
One of the questions that popped up was there was a section where it was asking you for AWS account credentials.
Yes.
That is what you were just alluding to just now of being able to either spin it up locally or spin it up in an EKS cluster.
Correct. With those first questions up here where I asked, here, I just went by them. There it is. Like, for example, asking for account ID, we use Amazon's, I can't remember what it's called, their SSO. It used to be called Identity SAML or whatever their SSO thing is. So putting in the account ID and then SSO, logging in, doing AWS command line SSO authenticate. Now you're authenticated, you have access to whatever that account ID may be, and that account ID could be your development account organization, or maybe you've got namespaces inside a single account where you're doing that. But we're not asking for any kind of secrets here.
Right.
Because we want you to use things like tools like SSO to be able to securely and safely do that kind of work.
Claim Your Freedom said Identity Center. I think that's right.
That's it. Yes. Yeah. They changed the name. It used to be something else. So
they're sneaky like that.
They are sneaky like that. They rarely get rid of anything, which is good, but has happened recently. Cool. Well, I'll kind of keep rolling here so I can get into some of the Python stuff, which will be more interesting. I did want to give, again, a little more background on Kubernetes and why it's interesting from a development standpoint. When you talk about Kubernetes, you'll hear these terms: nodes, services, deployments, and pods. And you could think about nodes as just a server, a host, whether it's a bare metal piece of equipment you have in your server closet, or if it's an EC2 instance up in the cloud, or even if it's EKS and it's managed, they're managing the nodes for you. That's just a server of some kind. So you'll see here, there's a node here with 4 CPUs and 8 gig of RAM, and you can have n number of nodes that can spin up and join the cluster and participate as you get more load. The next thing is pods. So a pod you can think of as a running copy of your application. So in this case, we can deploy some number of pods. So you can set replicas equal to 2. And if you have 2 nodes, you'll get a pod on each node. And same thing for the front end here. I got the React or the Next.js pod. That's just running an instance of those containers in kind of a name inside that space. And then you've got, you'll see up here the services like front end and back end. Those are just shortcuts for easy ways for you to access the things running in those pods. So if you've got a service running like the back end right here, it's running on port 800 and the target port is 8,000 and the target port is 8,000. Then when you ask for the backend, in this case, if it's named Django, it's going to load balance those requests across all the pods that are on all the nodes. It's actually not super complicated, but I think a lot of times you need to have those terms, kind of laid out in front of you so it's easier to understand. And then inside of a cluster, you'll have context. So in our case, a cluster is a context. For example, if you're using a development environment, that would be a dev context. So if I did a kubectl config get context, you can have many contexts configured on your local command line tool. And if you change between those contexts, you may be talking to something locally, or you could be talking to something off into the cloud. So for example, you may have development locally on Minikube or Kind. You may have QA on K3s in an EC2 instance, so like a single node, very small, very lightweight Kubernetes cluster. And you may be putting production into a hosted managed Kubernetes service like EKS or GKE or AKS, so that you can leverage the knowledge and the backplanes and control planes that are coming from those providers and their flavored versions of that managed service. That's all contexts is an easy way for you to move within the same command line between those different like places where it's running, different clusters. So those are your contexts. So each cluster is a different context. And then namespaces, which if you're in the Python community, you will know the namespaces are one honking great idea. Make sure you go and read the Zen of Python. If you aren't familiar with it, you can just write Python -m this. If you import the this module in Python, you'll get a little Easter egg, and that's one of them. And the idea is that inside of one cluster, you can actually have many namespaces. So I could launch 5 copies of my application, even though they're all called, the backend service are all called Django. As long as I launch them into 5 different namespaces, they won't interfere with one another. They can be running on the same ports, they can be running on the same names, but they've got that namespace so that you can actually have, for example, preview environments. This is what I mentioned in the very beginning as part of that ideal developer experience, is if you can have these preview environments and you can stack them all into one cluster, you can basically take advantage of running many copies of your application for testing purposes very easily and very lightweight, because you're leveraging one cluster or one set of resources to be able to run that. And so you can look at a specific cluster or context, get the namespaces, and see like feature X and feature Y are 2 separate running version instances of the whole stack of application, but one's going to have like the PR, the pull request for feature X, and one for feature Y. So just an easy way to run the same stuff in the same spot without having to worry about all the port numbers. Because again, as a developer, if you've ever tried to run a second copy of your app on your local machine, you have to go change the port numbers so that it can actually start up. Otherwise, they're both going to try to bind to port 8080, and you won't be able to do it without having to make hard-coded hand modifications. So this gets us away from those hard-coding like hand modifications locally. And so some people might ask, why not Docker Compose? Calvin, you seem all excited about containers. And I hear Docker Compose does containers and it's built into Docker. And it is. And I think that the big reason we've chosen Kubernetes versus Docker Compose is I don't want to have different container technologies or orchestration layers running at the same time. I like to have that kind of uniform through the local development environment to the production environment, because the issue with Docker Compose is you don't have that control plane feature, which I feel like is the killer feature for me as a developer on Kubernetes. So if I can use and deploy software with Docker Compose, but it's going to be that manual process of logging into a server, doing a git pull of the image. So at least you have that benefit. If you're using Docker Compose, you can still build an image, put it into a container registry, and use that same image from that container registry in your QA environment. And when it passes testing, you can just go pull that same image onto your production environment. So you've already got a benefit over just using a git pull out of the repository, like the code repository, because you're sure that nothing has changed to that code between the QA testing and the production release. But you still have to log in manually, git pull, there's still room for human error, or you're writing scripts to automate that process. And Kubernetes just provides that framework for the control plane to manage that whole process from beginning to end. And it gives you that declarative, I've released version 2 of this image. I can tell Kubernetes that version 2 is now the new version, and Kubernetes knows how to go retrieve that new version from my container repository registry and deploy it. And if it sees any failures, it knows how to roll it back. So again, Docker Compose doesn't give you those same kind of orchestration or control API features that I think you get with Kubernetes. So now the developer workflow, I want to show that off, and we'll do a live demo. Actually, that'll be the next step here. One of the cool things, so as a developer, you may be like, all right, now what? I got a set of junk all down here on my file system. This is the output from that Scaf tool I was just telling you about. So if you go to github.com/6feetup/Scaf, you can check out more information on Scaf and how to install it and get going with it. But in under a couple minutes, you can basically have a full stack of stuff running, and I'll show you what that looks like. So we're going to run tilt up. So you can see here, to get started, there are some little quick instructions up here. But basically, we cd'd into the directory, and we'll type tilt up. And you'll be like, what is tilt? Glad you asked. It moves tilt into, let's see here. We put it on another tab. Oops, there we go. There's tilt. And so tilt is it's basically a local developer orchestration tool that allows me to do a couple things. First of all, what tilt did in combination with, I kind of waved my hands around another part there you're not seeing, is we actually deployed kind locally on the system. Actually, I'll show that off over here. we'll do this. So Kind is a local Kubernetes cluster. Clusters. And now you can see there's a new cluster running called vBrownBag 02. That is what to the outside world looks like a full-blown Kubernetes cluster. It has a control plane. It has, it deployed those manifests, those YAML files into it, but it's running locally on my own local machine, and it's only running in one container. So if you actually look over here, I use OrbStack for a replacement for Docker Desktop. Highly recommend it. It's very nice, especially on a Mac. If you're not on a Mac, then Docker Desktop's going to be your option. Or if you're on Linux, you can just use plain old Docker and basically launch Kind Kubernetes clusters. But you can see here on my containers list for OrbStack, there is just one container running. It's this vBrownBag 002 control plane. And that lines up to what we saw on the command line here, which is this. And now if I do kubectl get pods, for example, you'll see I've got the backend, front end, Mailhog, Postgres, and Redis. That was all managed by Tilt. That's why I'm bringing up Tilt here. So if we click into the backend, you can actually see here, it gives me the status of when they build. It actually, more importantly, watches for changes on my file system. So if I change a file on the file system, like I'm editing code live and want to double check my change worked, Tilt actually has a file system watcher, and it uses rsync to sync those files up into the remote, it's locally running on my machine using Kind, but it's a remote cluster. So it syncs that file into the remote cluster, whether it's running locally or whether I had it running in an EC2 instance because I didn't have enough resources locally.
Without saving it?
Yeah, without saving. Well, you save it. I mean, like if you're using an IDE that auto saves, like PyCharm, every time I'm typing, it's just syncing the files up into the Django cluster, for example. So the same thing works for the front end and the back end. And if you change, for example, the Docker file, say you add a new dependency to your Docker project, like your Django project, now it depends on requests because you're going to be making calls to some API, and you add that as a requirements file, you're going to need to rebuild the Docker container so that it can pick up your new dependency. So when you make those changes, you can see here there's this initial build. So it did actually come up here. You can see it ran building the Docker file for the backend. So can you make the text a little bit bigger? Oh yeah. That's probably a little easier to see.
Yeah.
Yeah. So you can see here that it actually handles the Docker build and the deploy of the container. So step one is build. So it takes your Docker file. In this case, we got a multi-stage build. And it copies that in there. You can see the second stage is happening right here, and the output, is from the build image right here. The second part of this, we go down in here. It's still building. Is here. It pushes it into the backend repository. So it takes your image that it just built and pushes it into the local container repository or registry. And then it notifies your cluster via the backend services. You can see right here, backend service and backend deployment, that you have a new version of this container ready to go. And so it will release that container into the Kubernetes cluster, just like it would do in a production environment or a sandbox environment. It works alike. So that's the process for like building of the image. Now, the benefit of the next part I'm showing you is that once I've got the image built, you typically don't want to be rebuilding that image every time you want to like test a change to the code. So if we come down here, we'll kind of watch the bottom of the screen as I make a change. We're going to come over to some Python code. I'll go into the back end and we'll just find a quick little file. We can, let's go in here to models. And so maybe we just add a new comment in here. This is a comment and save. And if we go back over here, one file changed. See here, the users models.py. So it detected that, copied the file from your local file system into the container. So instead of rebuilding the whole container,
oh, that's slick. Okay,
it uses rsync to synchronize the file up into your container, and
that's why Kubernetes doesn't care if it's what the container version is.
Yeah, I don't care where, and I don't care where it's running. This will work in the cloud. Like Tilt will set up all the tunnels needed to go between you and wherever your cluster is running. It could be you could have literally a Intel white box on your desk side that's like super powered and got GPUs and all this other stuff in it, and still be using your MacBook Pro for doing development, and now you can enable things like doing CUDA development with NVIDIA graphics cards, but you don't have to have a graphics card in your laptop. It's sitting right beside you.
Nice.
Yeah. So then what's nice here is the next thing that happens is Django's normal reloading kicks in. Django itself, when you're running in debug mode, which this is running in debug mode because I'm local, will pick up the file change, and then you can see right here loaded the change of this right here. Same thing happens for like front ends as well. Like if we go into the templates and look at the let's look at the pages. We'll just edit this about page real quick. Oh, I guess I need to get base dot. Oops. Where's that at? Here it is, base.html. So it's like I'm trying to find the standard like text chunk. Well, here, I'll look at it real quick in the site so you can see it. It also gives you a nice little link right here to like localhost 8000. Boom, you've got your brand new Scaf power. So I'm just going to search for the word brand new and change it to something else. Brand new. Here we go. Open that up, and so
Nice.
Really cool. Brand new. And then we'll come over here, and if we refresh this page, you can see this is hosted in a Kubernetes cluster. That got pushed up, updated all in real time. And another nice part you kind of maybe noticing this right here is like this sidebar over here is the Django debug toolbar. So we can put all the developer creature comforts into our local version of this. But when we deploy onto staging, sandbox, production, you don't want any of that stuff anywhere near your code. Yeah, because you don't want any developer tools to be released as part of like that security surface area. And you don't want any other command line tools typically released as part of that surface area as well. So that's some more opinions that we have as part of our Scaf project and the stuff we do. Let's go back over here. And the last bit I kind of want to demo, unless there's any other questions about some of this piece I just showed, is going to be debugging. Because that's a really important fact. If people don't know how to use their debugger, I highly recommend you invest a little bit of time and look at some tutorials online. If you're using PyCharm, my good friend Paul Everett does some awesome videos on PyCharm and how to do that.
He does, doesn't he?
He does. I'll give him a little plug there for that. So actually, looks like we broke our docs up. So if we go into the docs, there's a whole document in here on debugging, and it's not hard actually. So what we're going to do is we're going to set up our remote Kubernetes cluster, which is running on my local machine in Makind, to enable full debugging. So, and then we got the step-by-step bits here. I don't think there's instructions yet for VS Code, but I don't think it'd be hard to put that in here. So if someone wanted to make a pull request, it's an open source project, so feel free. So we're going to actually go into this app config map, and we're going to add in an environment variable for PyCharm for our debugger. So that's down here in Kate's underneath our base. And here we go, PyCharm. So you'll watch when I change that. Let's go back over here to kind. You should see.
One file changed, yeah.
Oh, that was the template though one. It may not pick up that change. So it'll pick up a change to the Docker file. So it's something to kind of be aware of as you're doing this. It may not pick up everything. Because we changed an environment variable and a config map for Kubernetes, what we really need to do is relaunch that pod. But kind makes it easier because you can actually just manually trigger the update. So what we're going to do is we're going to manually trigger that backend update. It's going to relaunch that the image back into the cluster as a new pod. And when it does that, it picks up the config map setting. So down here, it's redeploying. You can see there, and it's done. So it just didn't even have to rebuild it because the image was already built. It just needed to relaunch, like kill the old pod and relaunch the new pod up into the thing. So that part of the instructions now were done. And then the next bit is going to be in PyCharm, for example, we're going to create a run configuration up here. Just go in here and edit configurations, and we're going to create a Python debug server bound to port 6400. So that's just right here. Go down to, I think it'd be easier if I just typed it. Python debug server. So this sets up a server, and you need to change this to not bind to localhost, because you're going to be wanting an outside thing technically to talk to an inside thing on your laptop. And we want it on 6400. So this is going to run a local server on your laptop or wherever you're doing your working. And it's going to, I think that's all I need to do. Yep. And we'll just call this Python debug server and click OK. So now we've got a Python debug server here. We can run that Python debug server in debug mode. And you'll see down here, basically, it opens up the debugger. It opens up a port or a listening socket on your local machine on port 6400. And now we can put breakpoints in our code to talk back to it. So you can see right here, you can basically copy paste this right in. Should just work. We'll see. And if there's then later I'll show you. Well, let's add this code in here first. That way you can check it all out. Let's go in here to views. And I think we'll add it into our user detail view. Yeah, we'll probably do that. Oh, another thing we need to do, since you've just set up this new instance, is you're going to want to be able to do things like set up your super user. Like in Django, you typically would run create super user. We don't do that part for you, so you still have to do the create super user piece here. But we do make it easy because there is a make file target. So if you just type make at the root of a Scaf project, it's going to give you a big honking help basically for it. And what you want to do is you want to get on a shell on the back end. So you can see here, shell into your running Django container. So if you just type make shell backend, look at that magic. You are now in the Django running container inside wherever it's at, whether it's remote or local, you're inside of it. And we now have the ability to run our manage, so if we just run Python manage and create super user, the magic just works. So I'm just going to create a user called admin org and a really super secret password.
1, 2, 3, 4, 5, 6. It's the same password on my luggage.
I won't make the rest of that quote. Okay. Now the magic, actually, let's go back over here to our browser and let's go back in here. And I'm going to go to /admin. And now you're your standard Django admin. And we'll just use that fancy username and password. And we're in. We've got our Django administration is in. And if we click on view site, you can now, you're logged in. Like you can see your profile, you can view my info. So this is actually where I was going to now put a breakpoint so I can debug editing of this like name of user admin my profile. So this should be the update user view. So user detail view, it's like magic. So if we go into update view, get success URL, get object, let's see if I think this should, we put it right here. Oops, not that part. Let's put in this part. So that's our debugger. Connect to debugger. Yeah, maybe we've got some more code here. Whoops. I'll just make some bogus code here that we can like step through if we wanted to. Foo equals 0, var equals foo. It's obviously not great code, but it will hopefully demonstrate the point. If we go back over here now to our tilt, we should see the views changed, which is super awesome. And we are running now in debug mode. Don't make me a liar, this should work. If I come in and put a breakpoint here now, at this point in my editor. So I'm using the editor's breakpoint feature, the editor's debug feature. Let's see, this is like flying without the wire, right? Come back to my profile, my info. So they see how I click my info and nothing happened? If I come back here, it's like, hey, I'll just see if we can I think we can auto detect. And it's going to be like, how do I map from the stuff in the container to the stuff here? I think that's good enough. And then if we continue, like just step, I think I have to click continue once. There we go. I am in my debugger, in that view, right where I put the breakpoint, and I can now step, into or over. So I step to var equal foo. You can see right here, foo equals 0. So I'm using a debugger, but the code is not running on my local machine.
No, it's right. Yeah,
It's
exactly.
it's in a Kubernetes cluster running in a container, and I think this part trips a lot of new and experienced developers up. It's how do I get that to work? And once you get that to work, you get all this awesome stuff here. For example, you can see that self is, all the editor stuff starts, just popping, and you're like, this is amazing. I want to be able to view the requests and all the things that are going on inside there, so you can see the cookies, and like you can dive deep and travel through the code and really get to the heart of why a problem's happening. Because sometimes you end up with a Heisenberg, and sometimes you're going to need to be able to step through code like this to be able to even figure out what's going on, and that's how you do it. And that is kind of the major point I wanted to make here, was like that all can work and really change your quality of life as a developer.
Awesome. So a couple of questions.
Yes.
First question: what? So developer wants to get involved with Scaf. They want to start playing around with this.
Yeah.
What knowledge do they need to have in their head to be effective with Scaf? Like what are the prereqs to be effective with it?
Out of the box, if you, for example, right now the goal is you're going to be developing a Django application. We assume you're going to know some Django. So you're going to basically build out a scaffold hello world of a Django application. Beyond that, I mean, the README kind of walks you through, like you saw there, we just follow the docs to insert the debugger.
So that's what I was asking. Do they need a lot of Kubernetes to even get going with this?
No. That's been part of my goal, is to really make Kubernetes fade into the background part of this.
Awesome.
As you progress in your journey, and for example, as you want to add new services. For example, if you were adding like Celery to the project, you may want to actually split Celery into its own set of pods so that you can scale it separate from the Django backend. And so that's something where you would have to learn some Kubernetes, or you may consult a DevOps person or a really knowledgeable AI LLM, and they'll kind of tell you in the Kubernetes world how that's supposed to be. Our goal was to lay down some best practice Kubernetes manifests, so you have a very solid starting point without a lot of noise. Part of my goal is sometimes you see a lot of boilerplate code, and Kubernetes is full of it, because you just see a lot of people just copy pasta around all the stuff, and it gets really hard to follow. So what we tried to achieve with this project was put down just the bits you need to know and make sure it's clear. Like, it should be almost self-explanatory. I mean, a lot of people love that if their code was self-documenting. It's not true. But we tried to make it as close to that as possible, so that you could do it. You could actually start the next journey into adding new services to Kubernetes as part of your application. But from a direct standpoint here, your next step is going to be, all right, now I want to release this into production. Well, that should be a matter of you deploy, and actually I'll show you that code right here. Something I didn't show you that's in here is not only do we have the Kubernetes code in here, but there's a Terraform folder. And if you look at this Terraform folder, there's actually a set of Terraform in here to build a cluster in your AWS account. So in this case, you could build out a cluster for my awesome Scaf project. It's based on what you just set up, and it's going to set up DNS and staging stuff, and it's going to set up instance types for your control plane. And since it's staging, we only really want one instance, and the control plane can also host all the pods. So it's a really cheap. Actually, this is a 3-instance, small K3s cluster that will actually deploy. Let's see here. I don't know if this one has the deployments in there. Oh, this is where you would target your Argo CD to. So, for example, once you have that up and running, there's instructions in here for how to do that, and you will launch your Argo CD into that cluster as an operator. And now, as you change code and commit code, and depending on what your branching policy is for Git and your GitOps, as you merge code onto, for example, a staging or a sandbox branch, it will automatically build. That's why GitHub Actions will build the container, put the container into ECR. And when that container is built and put into ECR, it will now tell the control plane, hey, there's a new version of the sandbox image. And then Kubernetes orchestrates the release of that code. That's the next step, and most of that's all outlined here for you, at least as a starting point.
Very slick. Very slick.
Yeah.
The other question that I had was, if somebody's already got in a project up and running, how easy would it be to port it over to here, or is this more for greenfield starts?
Again, it depends, but I think if you had a Django project and you were already using containers, like you already had a Docker file and were already building, you could sub your backend. Let me go back over the code here. You could sub out in this structure. You could basically lay down this structure on your file system and then sub out your Django project into the backend right here. This is a standard Django, project with config and settings and the requirements files for it all right here. And then there's the apps for this Django application. So the Django project is called vBrownBag 2, and it has a users app in there and a utilities app in there. And as you create new Django apps, they would just start lining up right inside of here. So you would just drop your stuff in here, and now all the build tools can build your stuff instead of this stuff.
Right.
I wave my hands there quite a bit.
Sure. No,
but you can still use this as the recipe for getting you into this new world.
Yeah, no, I totally get it. There's a lot more to it than that, but
there's
it's
a lot going on here. And
you wouldn't want to do it for a giant Django project that you've been running for years and years, but
you may want to move that direction. You may want to be able to move off of your current hosting. Maybe you want to go from GKE to EKS. Like, I think the nice thing with Kubernetes is it gives you some more flexibility. This setup also allows for, maybe you don't want to run your Postgres database in your Kubernetes cluster. Fine, we can run it. We can add Terraform into this code right now to spin up an RDS, and then you just go change the environment variables in your config map to point to the RDS instead of your own cluster's database.
Right.
So it gives you options. Like, sometimes it doesn't make sense to run your own database. You may want to rely on Amazon's managed versions of those services. Same thing for the Redis or Valkey.
Nobody wants to run their own database.
And you can make this Kubernetes cluster pretty much read-only. You could remove any bits in here that write to any kind of volumes inside this cluster. Like, you could actually, out of the box, this will use S3 for static and media files, no matter what. You could add into it a min.io locally and just change the environment variable to point to your min.io instead of S3, and away you go.
Keep it all local. Yeah.
Keep it all local if you wanted.
Nice. Very cool.
Yeah.
Pop your connection stuff back up so everybody can see how to get in touch with you. Here, I'll just plop that up bigger.
You can find me. I'm just Calvin at 6uf.com. I am Calvin HP across all the internets. So
all the things.
I gotta say, I've not actually been very active on Mastodon. That's not been a thing.
You've been a little low key recently, just in general.
Seems like it, yeah. I don't know.
You've been busy. Things have been popping for you.
It's true. Lots going on. Lots of fun stuff happening.
No,
this has been fun. I want more folks to learn about this stuff. And ping me on socials. It'll be a good way for me to spark a conversation, get more people engaged, let people know that it's not a big scary beast, and you too can run Kubernetes locally on your local laptop.
I'm going to go play with it. I'm actually starting to play more with Django. So this is a perfect segue for me to just light this up locally now.
Yeah.
So
and then the instance there will also install, I believe it installs a Strawberry backend on Django, so you can do things like GraphQL. And
Strawberry.
Yeah. How many R's in Strawberry, Chris?
3. I can pass that test. Beep.
I don't know.
Awesome.
Very cool.
All right. Well, so while we were doing this, I have a little giveaway tool that I roll the dice on, and everybody that has contributed in the chat channel gets to be put in as a submission to win the prize for the evening. And the winner this evening is Miss Stephanie. Stephanie, you are the winner of the $50 of AWS compute credits.
Congrats.
I have your LinkedIn I have your information via LinkedIn, so I will DM you the code for this evening's prize. Yay, Stephanie.
Yay, Stephanie. And she had a great question about the origins of the name.
Yeah, exactly. Claim is asking, what is the arcade game in the background?
Oh, another good question. We did that arcade game for PyCon 2018 in Cleveland, Ohio.
So heavy. That thing's so heavy.
Chris has carried it. Chris has literally carried it. So it's a retro Pi, running inside there. But I love the game Galaga. So the artwork on the back side, all on the sides of it, are all Galaga themed, but it actually says 6 feet up, like right up there in the lit part. So it was a 6 feet up gimmick we did in our booth at PyCon, and the high score for the 2 days of Expo Hall on Galaga won the door prize.
Mm.
I mean, I'm not great at playing it. I just love the artwork and all the stuff that goes around retro games. You can't quite.
And then
see
I
it.
had to schlep it to the after party.
You did
while you were wearing your pants, and I can't carry it because I got my sparkly pants on, Chris. I can't carry the thing.
No, actually, that after party, I was not wearing sparkly pants. I was wearing tuxedo pants. Come on.
Whatever. My pants. I can't. Chris, my pants. I can't. My pants. You got to carry it. My pants. Outrageous. All right.
Chris is a great roadie. I highly recommend him. If you ever need a roadie, just call him up.
I miss you. We need to hang out more often. You're not coming to reInvent.
I'm not coming to reInvent this year.
This is unacceptable.
No. I'll be actually, if you're in San Diego, I will be in San Diego next week for the 7 CTOs 0111 conference. So if you're in San Diego, give me a shout out and maybe come by for a drink.
I will not be there, unfortunately. My next thing is
this is an invitation to anybody in your crowd.
Oh, okay. So the next thing that I'm at is KubeCon in Salt Lake City. I'll be there November 12th to the 15th in Salt Lake City.
First KubeCon, right?
This is my first KubeCon. Yes,
that's a good one.
It's So several people are already excited about the fact that I'm going to be there. So. We'll see how that goes. They said, "Oh yeah, we're gonna take you out. We're gonna do fun things." I'm like, "Oh, okay."
I talked to Kapil this morning, and he will be there. You've met him at PyCon.
Oh, tag me up with him. I'll definitely hang out with him while we're there.
I know he's gonna be there.
Claim the way that I got roped into that was because so Calvin was wearing his pants, and so he couldn't carry it. Everybody else was either too small to carry it, or they already had their hands full, so it fell to me. I'm a big guy. I can carry a lot. So
you're handy.
Yeah.
It's handy.
I'm handsy. What? No.
Handy.
All right, everybody. Have a wonderful evening, Calvin. Always a pleasure having you on.
Thank you so much. I really appreciate it.
We're gonna have to figure out some ways to hang out.
Yeah.
And everybody have a wonderful evening. Stephanie, we'll get you the credits, and everybody else, thanks for showing up, and we'll see you again next time. Oh my gosh, that's how close to the end of the year we're going. I'm already saying see you next year. All right, bye folks.